Yeah, to get into the topic, this something I'm not teaching is something new for the developers, especially the C#.NET developers. So this is something that we need to practice all the time in our in our day-to-day routine activities. So for the junior developers, they will be writing the code in the traditional method. So this here I would like to provide few tips which improves their performance, like coding, which like they can improve their optimization techniques, and they can improve the code performance and reduce the lines of code, and they can mitigate the redundancy of the code, everything. So we'll be covering few topics under this. So here is a few topics. I mean, I have segregated this C# code optimization tips into the various sessions. So this is my first session. So I'll be covering only few topics under this session. So these are the few topics. So the first topic is the memory management and garbage collection. And the second one is asynchronous programming with async or await. The third one is parallel computing and TPL, the task parallel libraries, and importance of caching data, concurrency and thread safety, understanding and optimization link queue performances, and micro optimization and JIT compilation. So these are the few topics that we will be going through in this session. So yeah, let's get started with the first thing. So our first thing is the memory management and the garbage collection. So here I'm just showing that how we normally write the code, when we are not knowing of a few things that are available in the C#. If you don't know that, how we'll be writing the code, and if you know that, how we'll be writing the code. So I'm just showing the differentiation between the two things. So if you don't know that, there is a concept called iDisposable interface, and we don't know if we don't know how to use it, then we'll be writing the code like this to run to make something workable. And there's nothing wrong in writing this. Like you can see a class here, resource folder. So here we don't see anything wrong. There won't be any compilation errors, build errors, and nothing is wrong. So the code is perfect. But the only thing here goes wrong that invisible to our eyes is, so we are not disposing an object which is not in use for long. Like we are not using it, we are not disposing it. So consider we have a home, and in our home we keep a lot of objects. So, and if there is an object that is unused, so it occupies some room in our home, so which is not necessary. So we need to dump it or dispose that object. So the same thing follows. The same thing applies for our coding practices also. So you can see a private object here, a stream object, and this is an declared on the this is declared in the class. It's not a method level thing. So declared in the class, and this object will occupy its memory, like it won't get disposed if you don't use iDisposable interface. Okay, so the optimized way of writing, what is the optimized way? So we need to inherit the iDisposable interface to a class, and we just need to try to implement that iDisposable method. Like there will be a dispose method in iDisposable interface, and we just need to implement that, and we need to dispose that stream object. So by disposing that object, unmanaged object or unused object, every time as our regular practice, so we can prevent the memory leaks so effectively. Like there won't be any leakage in the memory. So this improves our program memory, like capacity type kind of thing. So that's one of the problems that we regularly see, and we just need to mitigate it by implementing the iDisposable. I just wanted to convey that point over here, which I think I did it. And the next thing is, we'll just move to the next thing. Avoid premature optimization. Now, what I exactly mean by avoid premature optimization. So this point also will be covered under this memory management and garbage collection only. So what I mean here is, so we all write code as our daily routine, and some of us will just write the code in a so sophisticated manner, like in an optimized way from the beginning. So that's not a wrong practice, I would say, but somehow it is not a good thing to write in a optimized way from the beginning, because sometimes it causes some disturbances in maintaining the code. Like if you wanted to change any object, we just need to search for the things like it's not open for modification. Starting, I mean, writing the code, starting from the beginning in an optimized way is not a good practice because it's not so maintainable. So what I would suggest here is, um, like I always say, like this is a bad way, which means here the people will be writing the code in a so optimized way from the beginning, which is not good for maintainability. So what we do here is we just need to write the straight code first, and we should make sure that whichever the task given, as we are meeting the acceptance criteria and all the test case scenarios were passed, and if everything is going well, then we just need to take some time and review our code by all ourselves before going to the peer reviews. And then, if you think everything is okay and the code is all code is ready for optimization now, then we start doing the optimization of the code. What do I mean by optimization here? So uh, everybody have their unique method of solving a problem when it comes to the coding part. So I find solution for my problem in a way that suits me, and some ex-developer finds uh, his thought process may be different. So the optimized way means we should just feel that there is no better way of writing the code than this. So that is the optimization that we give to our code, which means here, if you observe, first focus on writing clean and straightforward code, and then try to optimize it. So hope this point makes everyone clear. So we just need to write the straightforward code first, and then we should take our time to optimize it. When I say optimization, some people find, like if there are any conditional statements coming in, some people write multiple if else statements, like if else, else if, else if, else if, else if, and goes on. So if the data type is same, then we can go with the switch also. And few people follow the for loops morely. And if permits, like we can use the parallel programming concept. We need to go through it. Like we need to study that forward, and we can use the parallel programming concept to avoid the for loops. So these are all the time consuming process and the memory consuming process. So that's the reason we need to optimize our code to work our application in a better way. So that's all about avoid premature optimization. So you just need to avoid the optimization while writing the code itself. So that's the point. And in our index, the second topic is asynchronous programming with async await. So in that, the first thing is limit the number of concurrent operations. So what do I mean by this? Like we'll be having tasks, async operations to be performed in our application. So whenever we are performing, so managing the concurrency is crucial for C# programming optimizations. So by limiting the number of concurrent operations in our application, we help to reduce system overloading, like the overall load on the system. We help the system to reduce its overall load on it. So here, what we are doing, like in the bad way of code, in the bad way, sorry, in the bad way of code, tasks are spanned concurrently for each item without a proper limit. So there's a potentially it's causing significant strain on the system. Like there will be a lot of burden on the system if you don't put some maximum concurrency on the system, like how many times it has to perform the operation. If you don't put that, if you don't give that number, then it will do its, like there will be more burden on the system because it doesn't know like how many times it has to do the process. It has to execute the tasks. So that way, it's not a good practice to write the code in this way. Uh, so this is a bad way of writing the code. And the good way, what is the good way then? So using the semaphore slim. So these a class, this one class in our C Sharp, a predefined class, and um this class has a constructor which requires the maximum concurrency number. So we just need to pass the maximum concurrency number. Here, as you see, we are passing the maximum concurrency number as 10. So which means we are limiting the concurrency by waiting for the semaphore. And after all executing the tasks, and we are releasing the semaphore as well, release the semaphore. So we should, whenever we are trying to invoke the semaphore with await and async, and we just need to try to release it as well in the finally method, as we have seen here. So the semaphore was released in the finally method. So that's this kind of thing we should all practice when we are especially trying to work with async objects or with the tasks. So try to remember the word semaphore slim, and you can go ahead with that. Like if you wanted to know more about the semaphore slim, we can refer to the objects. Like we can refer to Google for that semaphore slim object, what it does, like how effective it is, like and all.
He's still not reading the call, guys. I think we lost him.
Oh, I think we lost you, yeah.
I was about to ask the same.
I think that
Yeah.
Naveen, yeah. Yeah, he
Can someone check
just wait
with
for a
him?
minute.
Yeah.
Yes,
I'm sorry, probably that's bad network. Yeah. Can someone check?
No
please?
problem.
Yeah, no problems. Some
No
problems in the connection.
Is he reconnecting, or Srini, can you take over? The meantime, can Srini, can you take over? Srini was there. This is crazy.
Yeah, I'm here. But not sure on the content. What I mean, the PPT, what our document is sharing.
Yeah, just the coding best practices. Naveen was covering the asynchronous.
Right.
Yeah. I guess sorry for this, Suarez.
Or
No
this,
worries.
this
Yeah, I think
That's fine.
yeah. Seems a bad connection Naveen is having.
Yeah, let's try to contact him and see if he's
Yeah.
able to rejoin.
Maybe. I mean, we can schedule one more meeting, isn't it? I mean, checking with. Okay, Vijay?
Yeah, you can, just in case if you would like to continue from where Naveen left. I know he was discussing on the code tools and the best practices of coding?
Yeah, I mean, there are a few things, but again, it would be better like if I just share that. I don't know any content right now to share, but maybe we
Hello.
can schedule one more.
Yeah, I'm back. I'm
Yes.
sorry.
Go ahead.
I did not realize like where I cut myself. So if you can help me, like till what point I have covered, I'll just share my screen again. So yeah, what's the last point that you hear?
Yeah. That one. Yeah, that one.
Use configure await, right?
Yes.
So did I complete this? Like you
No.
have heard it, right? Okay.
We're about to
So
start.
got it, got it. Yeah, sorry for that. So the next thing is use configure await of false. So there are two ways of writing the code. So we use configure await, like configure await method, especially to mitigate the deadlocks in our code. What do I mean by deadlock is, so there are two processes, like two execution process. One is dependent on the other, like the same way in vice versa. So the two process one is depending on the process two, and process two is depending on the process one. Like we can consider it in any ways, like the method one depending on the method two execution, and method two depending on the method one execution. So this kind of situation is called a deadlock situation. So that we'll rarely see in our code. But to mitigate that even rare scenario, we just use this configure await false method. So this one method, by using this one method, we can just mitigate the deadlocks in our code. So that's all about this use configure await of false. And the next concept is parallel computing and task parallel library. So most of the experienced developers might know like what is parallel computing and TPL libraries. So again, there are two ways of writing this code. One way of writing is the traditional method. Like few developers who have just started their career, they'll be using this traditional method. And when we see this kind of code, this is a straightforward code. We'll all know like what's happening here. So the execution point executes this point like for loop first, and then it comes, and based on the number of data.count number, it iterates it, like it will just loop into this. So we all know that how this code will be executed, but none of us know like how this will be executed. So this just the upgraded version of this particular for loop, this parallel for each. Now, why we need to do this? Firstly, there is no harm in writing the code this way or this way. The only thing is here everything happens in a sequential way. Like firstly, it executes this line, the for line, and then it comes to this one, and then this one, and for loop closes. Oh, sorry, it won't close, and then the I value get implemented, and the loop get executed until it comes out of it. And there's a sequential burden, and there's a time delay in completing all these things for the process. So in my way of coding, like that's the optimized way of coding, in the it just segregates, like it just distributes its functionality by using this parallel dot for each and data comma in item, like perform expensive operation. So whatever the method that we are calling here, the same method we are calling here, and by writing this line of code, we can distribute the work in a parallel way, like not in a sequential manner, but in a parallel way. We can execute this perform expensive operation method in a parallel way. So that's the best technique that we can use. Instead of for loop, we can use the parallel for each. So the next thing is use partitioner class for efficient workload distribution. So this is one more unknown class in our C#. This is the one more unknown class in our C#, like use partitioner. So what we are doing here is so we are like I shown in the above class. So we are doing the parallel for each here. Like you might be surprised here, like in the previous code, I have just shown like using the parallel dot for each is a optimized way of instead of writing a for loop. That's obvious. Like instead of using for loop, we can use the parallel dot for each. So that is I'm still standing by it. But there is even more better way of writing the code just to balance the load distribution. So we can still distribute the load. Even though we are using the parallel dot for each, we can still distribute the load by employing this partitioner class. So there is a partitioner class in our C#. This is a predefined class, and we can create an object for that partitioner class, and we can write the same parallel dot for each. And this way, by employing the partitioner class, you can efficiently distribute workloads into chunks, reducing potential overhead and improving load balancing among the parallel tasks. So by using this partitioner, we can divide the work into chunks, and we can distribute the load evenly between this in the server. Sorry, in the processors. So that is the use of partitioner class in C#. And the next topic in the index is like importance of caching data. So implementing data caching with in-memory cache. So yeah, as you see here, we are trying to call this method in the bad way of writing code. We are trying to invoke this method and get the object populated every time, every single time whenever this method is called. So we are invoking the same method and trying to get the same object. But what is the solution for this? Like without being this method called, can't we hold the object like in the cache? We can do it. So that's one of the optimized way. So what I'm trying to do here is I'm just trying to create at the class level, I'm just trying to create a memory cache, and I'm just trying to store that whatever the object that I retrieve in this method. So I'm just trying to store those values in this cache dot set, and I'm just returning the product. So likewise I'm doing, and now this cache will hold the data for until the application time session timeout. The good way demonstrates the use of in-memory caching to store product data and reduce time-consuming database fetches. So instead of going to the DB and get the data every single time, we are just trying to get it one time and store it in the cache and using this that same data again and again until the session timeout. So I'm very sure that everybody will be aware of this caching data. So sometimes this causes some problems also, like it won't clear the cache sessions. The session won't be closed properly, and the cache won't be cleared, and we'll be seeing the same data even though the database data has been changed. That will not reflect in the cache memory. So that time we used to see this kind of problems also many times. So we should be a little careful when we are using the cache. So we should also try to, whenever the changes are not reflecting, the DB changes are not reflecting in our code means. So firstly, we need to check out the cache memory, whether it's cleared or not. So that's one thing, importance of caching data. So we should be a little careful in that way. So the next thing is implementing caching without distributed cache systems. So the Redis technique. So personally, I got familiar with the Redis cache technique after working here only. So this is one kind of caching technique which we will be using. And as you see, there is no it is very similar to the previous point which I have specified, but here we are trying to use something in specific to the Redis. So earlier we used the memory caching technique. Like this is a memory cache technique, and here this is a Redis cache, and so that's the only difference as I can see here. So that's about implementing cache with distributed caching systems. So the concurrency and thread safety. So managing concurrency is a fundamental aspect of developing high quality applications. So ensuring thread safety can prevent undesirable bugs and performance issues. So we'll just see some what are those things, like use lock-free data structures when possible. So opting for lock-free data structures such as like current bag, concurrent queue, or concurrent dictionary, you can minimize contention, improve performance, and ensure thread safety in multi-threaded scenarios. So whenever we are trying to use the multi-threading scenarios in our application, like what is multi-threading again? Performing the parallel tasks, like one following the other. It's called like multi-threading concept. So when we are trying to use that kind of scenarios in our code, so we should not forget to use this concurrent bag and concurrent queue or concurrent dictionary, whichever suits at that point of line. So we should try to use them. So that way we can use the lock-free, it improves the we can minimize the contention and improves the performance and ensure thread safety and multi-threading scenarios. So that we can implement, that we can bring up by using this these classes like concurrent bag and those classes, and use efficient synchronization constructs. So here, so again, we can see a familiar word that we have explored in this session is semaphore slim. So we are using the same class again here while using efficient synchronization constructs. So utilizing these efficient synchronization constructs such as semaphore slim and reader writer lock slim or monitor can help you protect shared resources and maintain thread safety. So again, this is to protect again, these to protect the thread safety and minimize contentions and performance impact only. So this technique also used for that. Yeah, this semaphore slim or reader writer and lock slim, reader writer lock slim. So these are the two classes that we use. I have shown, I'm showing only one class here, but there is another class also, that is reader writer lock slim. So these classes, like by employing this, I'm apologies for this line here. So this is not the right one to be shown here. But yeah, I'll just explain in words. The efficient synchronization constructs like semaphore slim and reader lock slim or monitor allow you to protect shared resources and ensure thread safety while minimizing contentions and performance overhead. So that's one point that I would like to bring up here, and employ the interlock classes for atomic operations. So using these interlock classes, you can perform simple atomic operations without relying on locks, reducing contentions and improving performance again. So by using these interlocked classes, by using these interlocked classes, so we can improve the atomic operations without relying on locks. So without using the locks, we can improve the performance. And here in the bad way of writing the code, the lock keyword is utilized and ensured. So as you see here, we have used the lock keyword and ensured the thread safety during the counter. And in the new way, in the good way of writing the code, we did not use the lock keyword, and we just used the interlocked increment method. Interlocked in the class interlocked, we are just using the increment method so that the counter value gets increased. So that way we can just the interlock class lets you perform the simple atomic operations without using locks, resulting in increased performance and reduced contentions. So the next thing is understanding and optimizing link queue performances. So yeah, as like we are all aware of the link queue queries. So this we use mostly. Obviously, the link queues are meant to be to write the optimized queries or optimized. This link queue itself is a optimized way of writing the code. But even in the link queue, there is an even better way. Here, if you see, we have used the lambda expressions, and here we have used the traditional way of writing the code again. So somehow the syntax teaches me here, instead of using the lambda expression, using the traditional the query language, gives a much more performance. So using this instead of using the lambda syntax, using the traditional link queue query syntax improves the performance of our coding more. So I'm sure what we had, you all understood like what we are trying to do in the bad way and right way of doing the code. So that's one of the thing. And be aware of potential pitfalls when using link queue in multi-threaded environment. So there is a potential threat here. Potential pitfalls is a threat when we are working on multi-threaded things. So here we can how we can mitigate that with the link query is that we are showing here. So in the bad way of writing the code, we are just doing the parallel.forEach, and inside this we are just trying to items, comma item, and the optimized way of writing the code is create a separate link queue query for each parallel operation. So instead of writing the link queue query in one parallel for each operation, so we need to segregate that. We need to create, we need to separate the link queue queries in each parallel operations, and we need to write it. So that's one thing that we are trying to achieve here. And so moving to the next, I think this is the final thing to discuss today. So micro optimizations and JIT compilations. So perform loop unrolling for better performance. So yeah, I hope we all like this kind of things, even if we know that this kind of thing existed. So this is the for loop, and this is another for loop. Let's say my array consists of 100 objects or 400 objects. Let's say 400 objects. My array consists of 400 objects, and so array.length here and here both will be the 400, and you can just observe here how much difference it is. Like this will loop for 400 times, and this will loop for only 100 times. So which is drastically reducing my execution time. So this we have done a little thing to achieve this thing. So we just try to increase the I value 4 times and match it with the length. And inside this array, we are trying to execute that thing, like we are trying to execute an array of I into 2, and you can just follow the lines here. So they're pretty much straightforward, and you can just observe that by just implementing this, we have just decreased the execution time like a quarter, like 1/4 of the execution time is improved. So that's even this method, this technique, we can follow for thousands and even if it has to loop for 1,000 objects also. So we can use the similar kind of the technique. So that's one thing. This technique is called perform loop unrolling for better performance. Like perform loop unrolling, this method. So I think that's the end of the session for today. So yeah, I would like to cover, if I got an opportunity again, I would like to cover more optimization techniques in further sessions. So yeah, that's the end of the presentation for today.
For
So we
sure,
can,
Naveen. You can
yeah.
prepare as many sessions as you want. This
Yeah.
is in fact a very valuable information. Sometimes we forgot to use those techniques in our day-to-day. We need to solve the requirement, and we don't think in how we can improve the performance of our code using those techniques, maybe because we are in a hurry trying to solve the requirement. But yeah,
Yes,
this is very valuable information, very valuable techniques that we can use. Thank you so much, man.
Thank you, Ricardo.
Thank you,
I
Naveen.
have a question,
Sorry.
Naveen.
Yes, Emiliano.
Oh, Eddie.
Okay, and may I go first, Emi?
Yes, Eddie. Yeah.
Yes.
Okay. Okay, so in the first slide, in the first part of the session, Naveen, first of all, this is a very great session because of what Ricardo was mentioning about sometimes we just focus on solving the problem, but we don't focus on optimizing at the maximum way possible. So thank you for this session. And my question is related with the iDisposable interface. So let's suppose that I have, for example, 15 classes, okay? And I am creating different objects between the classes, and I am processing information in those classes. So the suggestion here is to use the iDisposable interface in all the classes, always?
It's only like based on the objects that you are using in those classes, Eddie. So end of the day, it's like I mentioned in the beginning of the session. So it's always the developer's choice, like how he wants to solve the problem. So if you feel that this particular class is taking more time in like it's not losing, it has more unnecessary objects that it's still carrying, even though that's not necessary. So for that kind of classes, yeah, I would request we all to implement that iDisposable class, inherit and implement it, the iDispose method, and dump all the objects that are not in use. So I would not like. I understand your question. Like we have 15 number of classes, and then I would never it's even tough to implement that iDisposable for all the 15 classes. But we can segregate, like there are 50 number of objects in one class that are just declared and used for once, and those objects did not got killed, and it is still carrying some data, and it is still occupying some memory. So in that kind of scenarios, yeah, I would suggest to go for it, implement the iDisposable interface.
Okay, thank you for your answer, Naveen.
Yes, sir.
Okay. Thank you, Naveen. I think, Eddie, we can stop the recording. This was a great session. I think that we need to repeat. Even I learned a couple of things. So thank you, Naveen.
Thank you.
Yeah, thank you so much, guys.
Okay, so if there is no more questions, we can finish the session.